All right, here's another edition of Endpoint Math. We're going to be talking about zeros and intercepts of functions. Won't that be exciting? All right, let's dig in. This actually will not take long. This is a very easy topic to go through. I am going to show you a little bit with the TI calculator, so you're going to want to have that handy. Just, I think, one or two of the problems we're going to refer to that. So before we get to that, though, let's get some vocabulary under our belts. So the y-intercept, it says, is the point where the graph crosses the y-axis. So here's the y-axis. So it looks like it crosses, this example right here, looks like it has a y-intercept of 0. I also have here in these notes, it's where the x equals 0. So the y-intercept in the example on the right is always going to have 0 comma something. So when x is 0, y is what? Well, we could read it off the graph. It sure looks like this is our y-intercept. So it looks like 0, 0 is our y-intercept on this graph. All right, what about the x-intercept? The x-intercept is where y is 0. So where y is 0 might happen more than one places. So in a function, you can have multiple x-intercepts, but by the way, you can only have one y-intercept because otherwise it would fail the vertical line test. If you had two y-intercepts, that would fail the vertical line test, all right, and it wouldn't be a function. So where are the x-intercepts? So I see one here, I see one here, and one here. The x-intercepts are at -3, 0, at 0, 0, and also 3, 0. So it looks like there's 3 x-intercepts. Now wait for it. There's another word for x-intercepts, and it's 0. The 0 of a function is when the function spits out 0. Remember, this side here is your output. So when it spits out 0, the question is, what was going in? Okay, so our zeros on the above example would be at -3, 0, and 3. We could list them in set notation, for example. So we just list the x values because we know the y values are all what? 0, because they're called zeros. So zeros of a function are when the function spits out 0. That's why it's called a 0 and why it's interesting to look at. All right, so I've got some simple examples here of a couple curves. So let me zoom in here. It says, name all the x-intercepts, which are also the zeros, as well as the y-intercept. All right, so let's start with the y-intercept. Where does it cross the y-axis? All right, so the y-intercept is at 0, 4. Make sure you put that x first, 0, 4. Now, what about the zeros or the x-intercepts? I see 2. I see there's an x-intercept at -2, 0. See how easy this is, and then 4, 0. And then I would also, I'll use a different color here just to drive it home, zeros, if I want to state it using that vocabulary word, I would say they happen at -1 and 4. There you go. So we've got 2 zeros of this function. It's when the output is 0. It's at x equals -1 and 4. Sometimes we say at x equals -1, 4. That'd be another way to say it, zeros. All right, what about this crazy thing? Oh my goodness, there's a whole bunch of things. But notice there's only one y-intercept. So the y-intercept is at 0, 0, or at y equals 0. You could say it that way. The x-intercepts, or zeros, are at x equals, where are they at? -3, -2. I'm not going to put a dot, dot, dot. Okay, I'm going to keep going. 0, 1, 2, and 3. So that's all I see right here in my graph. So isn't that easy? All right, so that's the concept of x-intercepts, y-intercepts, and zeros. So now it says use the graphing calculator to find the zeros. So let me pull up the calculator so that you can see it. There it is, and I got to turn it back on. Now, in the interest of time, I have already plugged it in, although I forgot that I had turned off the graph. By the way, if you're curious about how to do that, you just get over to that equal sign and hit enter, and it will toggle the graph on and off. So now it will only show that first graph, the y1. So I'm going to hit graph by the, let me show you this. My window, I've got it from -10 to 10 for the x, but the y's, I did go ahead and change them to -20 to 20 so that we see more of all the vertical action of these functions. And then I had it skip by 2, so there weren't 1,000 hash marks on the graph. All right, so let me hit graph. Isn't this exciting to see what it looks like? We know this is a parabola. This is an x-squared graph. These are called quadratics. This is a quadratic, so we know it's a parabola. And parabolas can have at most 2 zeros. They can have at most 2 zeros where it hits the x-axis. It can't hit 3 times, only 2 at most. It could also hit 1, or it could hit none if it was high enough on this graph. All right, where is the y-intercept? So I'm going to show you in the calculator how to find that. It's really super simple. You remember y-intercepts are always over 0, up something, right? Yeah, nod your head in vertical fashion. Okay, so when the x is 0, the y is what? Watch what I do. You ready? Second calculate. We're going to get into this screen here. So I did second trace, up to calculate, and I am going to do value, number 1. So I'm going to press the number 1, and it's going to say, oh, cool. What x value do you want? And what do you think I'm going to put? 0, because we want to know 0 comma what. So basically, we're plugging 0 into the function, and voila, it says y equals 5. You guys see that at the bottom of the screen, y equals 5. So my y-intercept is at y equals 5. Now, x-intercepts aren't quite as easy because the x-intercepts, or the zeros, they are x values. They are x values. So we can't plug an x in and get an x out, and we can't necessarily ask it. I mean, there are ways to do it, but I want to show you how to get it to show when y is 0. When y is 0. We're going to go back to that second trace, the second calculate. Go back to this screen. Look at number 2. What word do you see there? 0. It's going to tell us the 0. And it's just like the min and max thing that you may have done before. So you have to tell it what's called the interval. The left bound, I'm doing this backwards, the left bound and the right bound of where to look. So I want to look for a 0. I know the zeros, I'm using my cursor right now. I know my zeros right around here, right? So I have to go a little bit to the left. It says left bound, so I hit enter. And then I go a little to the right. I hit enter. And then says, okay, could you get me kind of close? So I'll go there and I'll hit enter a third time. And boom, it even says the word 0 on the screen. And it is at 0.3496. All right, so why don't you pause the video and see if you can find the other 0. And meanwhile, I will jump in and do that. Here we go, 3, 2, 1, second trace. We're going to find a 0, so I hit number 2. And this is going to take a little while. I got to click all the way over to the right here because I got to get close to the right 0. Here we go. Sorry, I'm not going to clip this out of the video. All right. There we go. All right, now I'm going to hit enter. Okay, that's called the left bound. And now I'm going to go a little to the right. This is called the right bound. So you can see how it's showing the region that we want to look. I'm going to back it up a little bit and hit enter, and there's the other 0. It's at 7.15037. And I'm not really rounding consistently here. Actually, yeah, 37. All right, so that's how you use the calculator to find a value, in this case the y-intercept, and then I use the calculator to find the zeros. And it was all that second trace, which is where you can find mins, maxes, and now you know you can find zeros and also values there. All right, so let me hide this calculator again because we are going to scroll down here and continue with these notes. It says the graph of a function is awesome. It's really helpful at times. But sometimes we can use our algebra skills to find intercepts. Both the x and the y can be found with just the numbers in the algebra. So how on earth do we do that? First of all, let's do the easy one. The y-intercept is always x equals 0. So what do? We plug in 0. We plug in 0 for x. And we get 0 plus 0 minus 8. That's negative 8. Well, that wasn't hard. There was really no algebra there. It was merely just a little bit of plugging and chugging, right? So the y-intercept is at y equals negative 8. Now what about the zeros? All right, I'm gonna utter a word that may strike fear into the hearts of some of you, and it is an F word. Ready? 3, 2, 1. Factoring. We're gonna factor this thing because when you factor something, you get its factors. You can set it equal to 0 and find what are called the zeros. Remember doing this back in Algebra 2 and Algebra 1. You factored a trinomial. I used reverse FOIL, and I've got several videos. Some of my most popular videos are reverse FOIL factoring because students struggle with that. This one wasn't too bad. You know, it was what multiplied to be negative 8 and then combines to be negative 7. It would be negative 8 and 1. So that one wasn't too bad. That's how I generally think about it and teach it. All right, so what am I going to do now? I set each factor equal to 0. So x minus 8 equals 0, x plus 1 equals 0. Because 0 times anything is 0. This is called the zero product property. So if we have 0 times whatever, we're going to get 0. If we have 0 times whatever, we will get our 0. So as long as one of those factors, or both, are 0, they're not both going to be 0, just one of them are at any given time, we'll have found what we call a 0. So I'm going to add 8. We get x equals 8, and then x equals negative 1 over here. So the zeros are at 8 and negative 1, and I would encourage you to graph that in Desmos or your graphing calculator and just prove to yourself that it really does hit at 8 and negative 1 on the x-axis. So those are called the zeros. All right, I've got another problem off to the right here. This is a cubic. And let me remind you what cubics look like. They can have a little wiggle in them, and they can hit up to 3 times on the x-axis. They will still only have one y-intercept. They will still only have one y-intercept. So how do we find the y-intercept again? The y-intercept is the easy one. That's where you plug 0 in. And if you plug 0 in there, what do you get? Oh my goodness, this is so easy. 0 minus 0 is 0. So that was no big deal. So the y-intercept is at 0, 0. What about the x-intercepts? Again, we need to utter the F word, not the one you're probably thinking when it comes to factoring. You're thinking, oh shoot, I have to do this again. Yes, we're going to factor. And first thing we do is GCF. These are both divisible by x. So I'm going to remove the greatest common factor. And then I set that equal to 0. So x equals 0 is one of the answers for the x-intercept. It's called a 0. These are called zeros. So x equals 0 is one of the zeros. Now I need to set the other factor equal to 0. And if I add 6 on both sides, I get x squared equals 6. I hit it with a square root. I'm going quickly because hopefully this is all coming back to you. And you get two answers, positive and negative radical 6. Positive and negative radical 6. So as it turns out, this graph hits at plus or minus. It hits at 0. Well, let me change colors here. It hits at 0, and then it hits over here at radical 6, which is like 2.5 or so. All right, so it hits over here at about 2.5, and then it hits over here at negative 2.5. So here's what the graph looks like. If you go to your graphing calculator, it should look something like that. I found all that out by analyzing the algebra and then my knowledge of what an x to the third looks like. And I was able to reason it all out. Notice I did put the first dot there also because remember that was also the y-intercept. So again, go to Desmos and check it. Now the next one has some extra information, so don't tune out here because you are not all knowledgeable just yet. By the end of the year, we'll get you there. All right, it's in factored form, so that's nice. We have a 0 generated by this factor and this factor. So we've got some zeros, and it's 3 and 1. Because if you set those equal to 0, like this, you end up getting 3, and then if I do it again, I get 1, right? X minus 1 equals 0, x equals 1. What about this other thing? Well, do you guys remember from Algebra 1, there was a thing called multiplicity, and we'll talk more about it this year, but when the multiplicity is even, when that factor is there like 2, 4, 6, 8 times, this graph hits the axis there but doesn't cross through. So I know that it hits at 7. So x equals 7 is another multiplicity, is a fancy word, multiplicity of 2. And that's even. So what does that tell me? That means the graph just crosses there momentarily. Watch how I set this up. So here's 1. Like I said, we'll talk more about this later in the year. Over here is 7. So I know the graph hits there just momentarily. I know over here and here it actually cuts through. I know that for a fact. So how on earth am I going to graph this? Well, x to the fourth, this is an x to the fourth graph because we have x squared generated here. We have an x to the first and an x to the first. So that's called a fourth degree polynomial. So fourth degree polynomials kind of look like this, almost like a tooth maybe, I don't know. So some sort of W shape. So how do I draw this? It comes down like this, it goes up, and then it just touches, and then it keeps going. Again, I'm giving you extra information here just to give you some insight into how this function rolls. Now, we haven't figured out the y-intercept yet. How do we do that? The y-intercept, we plug in 0. So to find the y-intercept, here's what I'm going to do. Something minus 7 squared times something minus 3 times something minus 1. And that something that I'm going to do is 0. Okay, so this is going to be negative 7 squared is 49 positive times negative 3 times negative 1. So I've got an even number of negatives, so I know I'm going to get 147 positive. So this hits at 147. So you might want to put that in your TI calculator and just see. And you know what? I did that before we gathered here. So I'm going to bring up the calculator again for you. And I am going to turn off this function. And I am going to turn this one on and hit graph. So you're going to see how it just touches the axis at that one spot. There you go. You see how that looks sort of similar to my graph. Now, what about the y-intercept? Remember how we did that? A second trace. I'm going to plug in a value, and the value that I'm going to plug in is 0. I plug in 0 and it says, you guys see that way at the bottom of your video? It says 147. So Mr. White does know what he's talking about. Isn't that cool? Not that Mr. White knows what he's talking about, but that we found the y-intercept without even a calculator. All right, what about this next one? I'm going to hide the calculator. We're done with that for today. This is another F word, factoring, and I'm going to use the grouping method. The grouping method is where you group the first two and you do a GCF on that. X squared times the quantity x minus 1. And then we look at the second two and we say, what do those have in common that can be divided out? Because I really have my fingers crossed that when I do that, I'm going to have what's called a common binomial. And I do here. I have a common binomial. So I then factor that out, leaving behind my x squared plus 10. And I have, like I said, lots of videos on factoring. I go through the grouping method on one particular video. We're setting that equal to 0. So when is x minus 1 equal to 0? That's at 1. When is x squared plus 10 equal to 0? Never. Wait, what? Never? Yeah, if you subtract 10, this is an imaginary problem. You're not allowed to square root a negative. So no x-intercepts or zeros are generated by that one. So there's only 1 0, and it happens at x equals 1. Now what about the y-intercept? The y-intercept I'll do up here. What is 0 minus 0 plus 0 minus 10? The y-intercept is at negative 10 on this graph. Now, I didn't plug this in. I would encourage you to go to Desmos and go ahead and plug that in and see what we got there. I have a feeling it hits at negative 10, and that the graph only hits the x-axis at one place because it only had one real 0. It had two imaginary, they're called roots. We'll talk more about that later in the year. The imaginary roots do not generate any, they don't generate any zeros. All right, so hopefully you're feeling somewhat good about finding x-intercepts and y-intercepts. All right, and we'll just keep practicing this, and pretty soon it should come easy working with the calculator. So hopefully this was good practice with the calculator. All right, well, until next time.